Hi guys, so we'll be solving an O-level past paper question from the year 2015. The session is May-June. This is question number 10. This question is based on transformations, symmetry and rotational symmetry. So let's start. In this question, they've given us two triangles, and please do not mind these lines over here. I tried to do this video once before, but I messed it up. So anyways, there are two triangles given over here. The first part says describe fully the single transformation that maps triangle A onto triangle B. Then we have to put our answer over here. So how do we do that? First of all, let's connect these 2 points because they are similar, and then let's connect these 2 points just like this. Okay, the next step is pretty simple. What we have to do is we have to draw perpendicular bisectors for this and this line. My compass is a little flimsy, but I'll try my best to draw as perfect lines as possible. So one of the arcs goes like this, and the other arc goes like this, and this arc goes like this. Oh my god, this compass is giving me a hard time. So this arc would go like this, and the other one would go like this. Okay, let's connect these two lines, and they pass through this point 1 and 1. Okay, this point over here. Okay, the next point is that we connect two arcs over here because we're trying to draw the perpendicular bisector of this line over here. So we draw an arc like this and another one like this. Then we put our compass over here, and without changing its position, we draw an arc like this and another one like this. Okay, so this is pretty straightforward, and I think this would be a perfect one. We draw a line that goes like this. Okay, so this is the point of intersection. I am guessing it is not going to be over here. It is going to be perfectly over here. That's because of my compass. So since two perpendicular bisectors intersect at this point, this is the center of rotation. And then what do? We connect this point with this line over here, and we connect this line and this point over here. And if we measure this angle, if we put our compass over here, this is going to be a 90-degree angle. And since A is going to be mapped onto B, this becomes a rotation of 90 degrees, which is anti-clockwise, about the point 1 and 1. 1 and 1 is the center of rotation. Okay, the next part says triangle B is mapped onto triangle C by a translation vector -2 and -3. Draw and label triangle C. So we have to move every point in B to the left 2 points and then down 3 points. So if we move this point, goes 1, 2 points to the left, and 1, 2, 3 points down. Over here, it comes over here. Then this point 1, 2 and 1, 2, 3 comes over here. And then this point 1, 2 and 1, 2, 3. This comes over here. If we connect these 3 points with a scale, this will give us our triangle C. So we're done with this part. The next part says triangle A is mapped onto triangle D by a reflection in the line y equal to x. Draw and label triangle D. First of all, a line y equal to x would be somewhat, this is going to be somewhat like this. I hope this is visible. It is a line that is perpendicular. Oh, sorry, it's a diagonal line for this grid. So I'll extend this over here like this. This triangle is mapped onto triangle D by reflection in this line. So this point comes over here, this point comes over here, and this point 1, 2 and 1, 2 comes over here. Okay, so if we connect this, and then we connect these 2 points, then we connect these 2 points, we get our triangle D. So we are done with this part as well. The last part says triangle E is geometrically similar to triangle A and its longest side is 12 centimeters. Calculate the area of triangle E. So if we look at triangle A first, if we consider this line to be the base, this is going to be 3 centimeters, and the height of this triangle is going to be 1 centimeters. So now what do we have to do? Since triangle A would have an area, how do we calculate the area of triangle A? Triangle A has an area of half times 3 times 1, which gives us 3 over 2 centimeters squared. Now if you look at this shape, triangle C has the longest side as 12 and triangle A has the longest side 3. So if we compare the two sides, 3 is to 12. If we simplify this, we get 1 is to 4. Now the thing is, since we're talking about the area, we need to square these lengths, 1 square and 4 square. This gives us 1 is to 16. And since the area of triangle A is 3 over 2, this is being compared to the area of this. So this gets multiplied by 16. When we multiply this by 16, we get 24 centimeters squared. So our area for triangle E would be 24 centimeters squared. I hope this part made sense. The next part, let's do it. The next part says, state the number of, so we have this shape. I hope this shape is visible. It says, state the number of lines of symmetry of the octagon. So this is pretty simple. If you draw a straight line right through the center, imagine this is the center, might be a little crooked. And then if you draw a line like this through a horizontal line like this, that's also going through the center. The lines of symmetry are 2. The next part says the cross section of a prism of an equilateral triangle. State the cross section of a prism is an equilateral triangle. State the number of planes of symmetry of the prism. If I draw this shape, imagine this is an equilateral triangle. Not the best of my drawings, but this is an equilateral triangle. So if I draw a line that goes like this, then I draw a line that goes like this, and then I draw a line that goes like this, that means there are 3 planes of symmetry right here. However, if I make this shape, if I stand the shape up and I draw it like this, I can also divide the shape in 2 halves if I draw a line right through the center. That means there is one plane of symmetry right over here. So we do 3 plus 1, this gives us 4. So our answer to this part is 4 planes of symmetry. The next part says, name 2 special quadrilaterals that have exactly 2 lines of symmetry and a rotational symmetry of order 2. First of all, the simplest shape that comes to mind is a rectangle. Why? Because you have 2 lines of symmetry right here, and this can be rotated like this and then like this once again. So it has an order of rotational symmetry of order 2 as well. So you write it over here. One of them is a rectangle and the other one needs to be similar to this, and it only needs to have 2 lines of symmetry and a rotational symmetry of order 2. So if I draw another shape like this, right, this is a rhombus. I have a line of symmetry that goes through the center, that's vertical like this, and then another line of symmetry that goes through the center, that's horizontal. So this also has 2 lines of symmetry and a rotational symmetry of order 2. So my second shape would be a rhombus. And we are done with the question. I hope this question made sense. The complete working of the entire question is present in the description below for you to download. If you like this video, hit the subscribe button, and thank you so much for watching.